Okay, we'll go into the next session, day 2, session 2 of this 2 days national workshop on MATLAB for Physicists. Okay, so in this session, we are going to deal with file operations in MATLAB, and further we'll see some applications in statistical mechanics. Okay, so coming to file operations. So whatever data we are developed in Octave environment can be stored into file, and the stored data from file can be accessed into this Octave environment. So let's say I'm generating a random matrix. Let's say X is equal to rand3. So it generates a 3x3 random matrix. And I want to calculate y, x square, and store it into y. So I'm going for element wise multiplication. So y is equal to x dot square. That generates square of the individual elements in the matrix. Okay. So now another operation, let's say z is equal to x plus y. So there are 3 variables, each of 3x3 matrix. So I want to store it into a data file. The simple option is save. So for that, see the help file for save. Help save. Help save. Type in help save. You'll see how to use that command help. Save. So here save minus binary. It is the format of the data. Data is the name of the file. AB are the variables. So you have to specify type of saving, name of the file, and the variables to be stored. There are different methods of storing it: binary data, float binary, HDF5, ASCII mode is also there, ASCII, append. So these are various options available. So save in the brackets whatever options followed by file name in quotes and the variables. So what I'm doing here is you don't need even to use the brackets. So I'm going to write save data file. So data.text, data.txt, and my variables x space y. Save data.text x space y. So go to that location. Where did you save this file? You can search. That is pwd, path of working directory. So the file is stored in C drive users HP. So if I go there, so this is the test.txt file. So already some data is there, so I'll replace it. I'm deleting that. I mean, there are some data already existing over there. So I'm freshly creating that file, test.txt. Sorry, data.txt. Sorry. So it is data.txt. So it stores entire information that you see on the command prompt. So created by Octave 9.2.0, Friday, November 22, 1420, 44, 2024 GMT. User unknown academic cell GCRJY. So name of the variable is X. Type of the variable is matrix. It contains 3 rows and 3 columns. Then the data is presented here. So hash stands for comment. I mean, it will not be considered as data in MATLAB or Octave environment. So this hash symbol stands for comment. So in total, there is a 3 by 3 matrix X and another 3 by 3 matrix Y. So the name, type of data, and specifications of that data is being stored in the file. Okay, and I'm closing it, and I want to add the other variable Z also to this file. So what shall I do? I have to save minus append data.txt Z. This will store, this will append the third element to this file at the end of the file. So XY data is existing, it is not erased, and finally Z data is added at the end of the file. This is what happens if we use the option append. And if you don't use the option append, what happens? So save data.txt Z. So now the file contains only the last information written to it. It carries only Z. Okay. Then let us see how many variables are there in this environment. So in this session, I have defined 3 variables X, Y, Z, and there is an answer stored, a character string of 1 by 11 length, which is an output for PWD command. So these are the total number of variables existing in this environment at this moment. So now what I do is save. I just specify the file name without specifying the list of variables. Let's see what happens. So I mentioned the file name and I did not mention any variable names. So if I specify the variable name, only those particular variables will be stored. But now I'm not specifying any variable names. I just gave the file name, then see what happens. So it stored the entire data available in the space. It stored the output of that PWD command. It is a 11 character length string. C users HP, variable X, variable Y, variable Z. So all the variables that you have defined in the Octave environment will be stored if you don't specify the name of the file. Okay, and I do one more thing. There is another option, save minus ASCII. Save minus ASCII data2 dot text X, Y, Z. So I'm defining a new file and I try to write three variables X, Y, Z into it in ASCII mode. Let's see what happens. Save minus ASCII data2 dot text X, Y, Z. All are separated by spaces. So data2 dot text. So it contains only the numerical data three matrices. What if I write AN as answer also? Let us see. So we got three 3x3 matrices written one after the other. X, Y, Z. Data only is written here. So now minus ASCII minus append data2 dot text. What is that data? ANS, answer. Let's see what does it do. So it gave the previous answer. What is the previous answer? Nothing. 6598. So some random numbers have been stored. So it is actually 11 characters in their ASCII code, probably. Count the number. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, there are 11 characters in their ASCII codes. So let's check what is that 6.7 into 10 power 1, 67 ASCII code. So let's check that. 67 ASCII code. So 67 ASCII code stands for C. Letter C. So whatever those 11 characters, C colon backslash user HP, entire the data is now stored as ASCII format. You can even check ASCII code for 92. Is actually a backslash. ASCII code for 92 is a backslash. So like that, entire data will be stored in ASCII format. Okay. So we have stored data basically in two formats. One, complete data with complete information. Another in ASCII format. So the data.text carries full information and the data2.text carries ASCII code. Now, how to get back the data? Let's say I'm clearing this environment. So all my variables are disappeared now. So in workspace, I have no variables. And clear the command prompt also, command window also cleared. CLC, clear command window. So now I try to load the data back. Load data.text. So once you load it, it loads entire data as it is. There is a character type of variable answer with 1/11 character string. Double precision real number variable x with which carries a 3x3 matrix. Another 3x3 matrix y, 3x3 matrix z. So entire data is retrieved back from the file. So you can even access. So if you clear the data, let's say if you type in clear all data will be cleared. And if you try x is undefined, y is undefined, z is undefined. So everything will be undefined if you use clear all. So all data will be erased. So now we can retrieve it back using this. So now let us see what this data2.text give if loaded. So data2text file format is unknown. Why is it unknown? Because it contains all 3x3 matrices as set, and in the last line there are 11 elements that cannot be stored as a matrix. So for the time being, let's say I'm removing this last line in data2. That 11 ASCII code string I've removed. Now there is a 3x9 matrix. Now I try to load that data. Now the data is loaded. It is a 9x3 matrix. So size. So the name of the variable is file name itself. So file name is data2. The variable created here is also a data2. It is a 9x3 matrix. So if the data is an ASCII code, that must be square or rectangular matrix. If there are any additional terms in one row, it cannot be loaded. Let's say every row contains three elements, and all of a sudden some row carries 4 or 5 elements. the data cannot be loaded into MATLAB environment. Okay. So the entire data must be of this type. So now let's say sometimes you may have title for this data. Let's say X data, Y data, Z data. So if your file contains numbers as well as if the first row contains labels for those numbers, in that case, can we load it? We'll try to check it. So I'm clearing all the data. So there is nothing in workspace. So now I try to load data to .text. So it is not able to load the data. Because there is a text information which is unknown to it. And suppose if we give some ASCII data there also, let's see what it gives. Let's say what is the ASCII codes that we have seen. 92 for backslash, 67 for C. So keep 92 here. '67, another 92. Let's see what happens. So I'm again clear all. Actually, there is nothing in the workspace. Now I load data to .text. So now it contains a 10 by 1 matrix. So there are 10 rows, a 10 by 3 matrix, 10 rows and 3 columns in data to variable. And I see what is that stored in it. So output is just numbers. I mean, I can't even get back the ASCII code. Whatever numbers I've entered are being represented as numbers. That's all. This is 92, 67, and 90. Okay. So most convenient method for importing and exporting data is using save without any further options. And if you want to use it for, let's say, if you take this data and use it in Excel or somewhere else in Origin or somewhere else, then you may need the data in this format, in specific formats in ASCII code, most of them. So there also you cannot paste text into that file. So that part you must be careful. So overall, if you use ASCII data format, it saves only text. Whereas without any option, a conventional method of data storage is it stores entire data. Let's say I'm clear it again, clear all, and load data.text. So now the entire data, whatever way we have in the previous workspace, is completely retrieved back, including the variable names and variable types. So this is how we can access data to and from in Octave. And there is another option, IO PKG load IO tools, input output tools. So if you load that, you can import the data from Excel file also. So then you can use XLS read, XLS write options. Like let's say if you have an Excel file, Microsoft Excel document, data dot XLS. So in that I'm storing some data. Let's say X, Y, and Z. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. So this is my data. So X, Y, Z columns. They may be considered as labels. And then the data. 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, 8. This is my data, and it is stored in the name data.xlsx. So now once you load the package IO, you can use XLS read. XLS read in single quotes, round brackets, data.xlsx. So it reads only numerical data from Excel file. Now if I want to help XLS write, or status XLS write file name array WSH and range. This is how you can write. So XLS write data.xlsx comma, I want to save my variable X into it. So the file is already open, so I'm closing it. So answer is 1, means it is successfully written into that file. So XLS write data.xls x. The variable x is written into that file. Let's check what is written. So whatever existing data is overwritten. I mean the data is not deleted, but wherever required, it is overwritten. So the previous first three columns data is deleted, and new data is overwritten into those cells. Let's say if you want to append the data into XLS read. We need to check. So you can specify the location where the data to be written. Otherwise, so let's say if you want your data to be written into so we used an option append. Let's see what it does. Nothing. The existing three rows were overwritten. So if I specify a particular cell like 8A to 10C, instead of this, if I specify 8A to 10C, now it stores properly. So I'm specifying the starting cell where from my data to be written, 8A. Nothing. It does nothing. Okay, so that part can be explored later. So now we go to random number generation. With that, we'll close the session. Okay. Uh, how to use random numbers for statistical analysis. And for specific statistical applications, there is a toolbox called statistic. Load pkg statistic. Pkg load, sorry. Pkg load statistic. It is also built in now, so don't need to worry, you don't need to load it. So this statistics package contains all these commands built in. All clustering functions. Data manipulation functions, graph to IDX. Yeah, descriptive statistics, mean, mode, median, all these functions, standard deviation. All these functions are now built in. So you can use all these statistical tools, mean, mode, median, standard deviation, variance. Everything can be calculated using a single command instruction. Okay, so now we try to perform this coin tossing experiment, which is a fundamental experiment for entire statistical mechanics. File operations. Okay, so writing a new script and saving it as tossing.m, tossing, tossing.m. So now my aim is to check coin tossing and calculate the probabilities. Let's say I want to toss a coin for 100 times and check how many times head appears and how many times tail appears. And I want to draw a probability distribution curve. Number of heads and number of tails, like a bar diagram, let's say. Okay, so that is my aim. And I want to give this instruction to a computer to automate the counting of coin tossing outcomes. So I toss a coin and check whether it is head or tail, and the computer has to count it as 1 or 0. I mean, it has to raise the counter for heads or counter for tails. How to do that? Automation. How to tell the computer that particular outcome is head or a particular outcome is tail. I mean, you toss a coin and enter the counter. That's one possibility. And how to automate that? Even the coin tossing can be automated. we can give that task to computer. So it does some activity and check the outcome as head or tail and rise some counts. So that can be done. So for that purpose, the basic idea here is the outcome of coin tossing experiment is random, completely random. I mean, we don't know in which trial you get head and which trial you get tail. So that is why I'm going to use random numbers to simulate the experiment. So the basic definition of random numbers is, let's say if you enter rand in the command window, it gives you some number. Let's say rand 1, 10. It gives you 10 random numbers. So the command I have entered here is rand 1, 10. Rand round brackets 1, 10. So I got 10 random numbers ranging from 0 to 1. Okay, so now I can instruct the computer that if the random number generated is less than 0.5, count it as head. If it is greater than 0.5, count it as tail. Okay, so then how to write the program? Try to use an if condition. If the particular entry is less than 0.5, you have to raise the counter for head. Otherwise, if it is greater than 1, counter for tail should be raised. So that is a 4-5 lines of code, right? So you'll get some 4-5 lines of code. Like you'll be storing all the 50 or 100 outcomes of random numbers into a array, and you will check each and every element whether it is less than half or greater than half, and then raise the counter respectively. If it is less than half, you will raise the counter for head, and if it is greater than half, you will raise the counter for tail. What if you want to extend the experiment to 3 coin tossings, 2 coin tossings? Let's say if I am extending it to 10 coin tossings. So I have to write 10 times the same code. For coin 1, a paragraph of code. For coin 2, another paragraph. For coin 3, another paragraph. Process. That's what we'll see. What is the outcome is a matter of discussion. We'll see the outcome also. Okay, so it is a tedious process. Every time you have to raise the counter and check what is the outcome. So there are some built-in commands which does the job for us. So I'm generating. So now go to this tossing.m file. I'm generating 100 random numbers, rand 1, 100, semicolon. So I'm generating 100 random numbers and I store it in a variable called a. A is equal to rand of 1, 100. So now I can give another command. I'm developing another array. B is equal to A of less than 0.5. Let's check what is the output of this. So what I'm doing is A is equal to rand 1 comma 100. That gives me 100 random numbers. And then B is equal to A less than 0.5. I'm placing everything in a bracket. B is equal to A less than 0.5. Okay, so I'll see this output also. B is equal to, so B is equal to round bracket A less than 0.5. So that gives me, if the condition I'm placing over there is true, that gives me 1. If the condition fails, that gives me 0. Let's see the first set, column 1 to 13, first set. The first number is 1, 2, 3, 4, 5 are zeros, 6 is 1. Okay, the first number is 1, 2, 3, 4, 5 are zeros, 6 is 1. Let's see what is the data actually. So first element is less than half, second, third, 4, 5 are greater than half, 6 is less than half. I mean, you may get a different random numbers, but the rule works. So wherever you have your condition succeeds, you'll get 1. Wherever the condition fails, you'll get 0. And the entire data will be stored into a new variable called B. So this is the command. B is equal to, in a bracket, in a round bracket, A less than 0.5. So when you use a round bracket, that particular command will be executed separately and the result will be applied to or stored into the variable you are specifying. B is equal to round bracket A less than 0.5. So I'm using that in my further programs. B is equal to A less than 0.5. Now, so I got all the data. So now I have to count number of zeros and number of ones. So how to do that? Simple option is hist B. Histogram will identify the number of variables and sort them, count them, and plot it. Everything in one shot. So histogram command will identify different types of variables in the given array, separates them, counts them, and plots them as a bar diagram. Let's check it out. So now in this experiment, I got 40 heads and 60 tails. The entire coin tossing activity is now reduced to simple 3 steps. So in the first trial, I got 40 heads and 60 tails. Most often, I should get a number around 50. So in the second trial, I got 45 heads and 55 tails. If I run it for another time, I got nearly 48 heads and 52 tails. You can check this. I got 49 heads and 51 tails. 49 heads, 51 tails. If you keep the pointer on the tip of that histogram bar, you can see the count. So I got 49 heads and 51 tails. So if I repeat the experiment again, now probably 48. 48 heads and 52 tails. So like that, you can repeat the experiment and see the outcome. Now comes one interesting question. So I want to test the outcome of 2 coin tossings. So for a single coin tossing, the outcome is nearly equally distributed, around 50, right? So one is 48. One time I got 48 and 52, another 49, 51. So like that, the outcome is almost nearly equally distributed between the two outcomes. Now I want to toss 2 coins together. So I may get either 0 heads or 1 head or 2 heads. There are 3 possible outcomes. Will they be equally distributed? What is the probability? Will I get 1/3, 1/3, 1/3? 2 coins. Three possibilities. Head count. Either 2 heads or 1 head or 0 heads. I mean, that is what we are counting here, right? Either 0 heads or 1 head. So when you toss 2 coins, the outcome is 3 possibilities. Either 0 heads, that means both tails, or 1 head, means 1 head and 1 tail, or 1 tail and 1 head, or both heads. 0 heads, 1 head and 2 heads. So I get 3 possible outcomes. And what is the basic general prediction says? All the 3 are equally probable, right? For 2 possibilities, we got equal probability. Heads got 50% probability, tails got 50% probability. Now I got 3 possibilities: 0 heads, 1 head, 2 heads. Will I get equal probability? So let us check that experiment. So I create a new file, new script, and I save it as tossing2.m. tossing2.m. So my A1 is rand 1,100. A1 is rand 1,100. So B1 is equal to round bracket A1 less than 0.5. Then I'm taking my second variable, second coin. A2 is equal to rand 1, 100 and counter B2 is B1 less than 0.5. Now I have to add the total outcome. So B is equal to, I'm defining B is equal to B1 plus B2. Then hist B. That is the outcome of two coin tossing experiment. Check down. So B is 1 by 100 matrix. B1 is 1 by 100 with zeros and ones. B2 is also 1 by 100 matrix. So wherever you have zeros in B1, there you got ones in B2. So that entire B became 1. It's a wonderful magic. Sorry, did I do? I had to use A2, right? B2 is equal to A2 less than 0.5. B1 is A1 less than 0.5. B2 is A2 less than 0.5. Exactly the question. Yes. So now check the output. So you got 0 heads possibility 25, 1 head 50, 2 heads 25. The outcome is 25, 50 and 25. So they are not equally distributed. Maybe you will try it once again and see whether we get a equal distribution or not. How many other times you try? You get around 25 for 0, around 50 for 1, and around 25 for 2. So what is the issue? What is the issue here? So let's say what are the possibilities you have for 0 heads? The possibilities are for 0 heads, 2 tails is the possibility, and for 1 head, tail head and head tail is the possibility, and for 2 heads, this is the only possibility. TT, TH, HT, HH. Right? So for 2 coin tossing, the possible outcomes are microscopic level. Microscopic possibilities are what? Both tails is counted as 0 heads. Tail head and head tail both are counted as 1 head. Then 2 heads is counted as 2 heads. Right? So the microscopic outcomes are these. And what are the macroscopic outcomes? Macroscopic outcome is 0, 1, 2. So for 2 tails, macroscopic outcome is 0. For tail head and head tail, for both microscopic outcomes, macroscopic outcome is 1. And for both heads, macroscopic outcome is 2. So final count is 2. Right? So the first postulate of statistical mechanics says whatever may be the macroscopic outcome, all microscopic outcomes are equally probable. All microscopic outcomes are equally probable. So this is the first postulate of statistical mechanics. Whatever may be the macroscopic state, so irrespective of macro state. So here we have got two microscopic states for a single macroscopic outcome. So all microscopic states are equally probable. What does that mean? So this will get 25% probability. These two will get another 25%. And the last one gets another 25%. Overall, so coming to macroscopic states, The first one gets 25%. Second one has contributions from two cases, so it gets 50%. And the last one gets 25%. So this is the first postulate of statistical mechanics. Second postulate deals with experimental outcome. I mean, if you perform an experiment and measure the outcome, you'll get same outcomes as the statistical result. So the second postulate says statistical average is equal to thermodynamic average. This is the second postulate. Statistical average is equal to thermodynamic average. Statistical average means the average you have calculated using probability rules. So whatever rule you have got here, I mean, you got 25% for 0 heads, 50% for 1 head, and 25% for 2 heads. The same thing will be repeated if you perform an experiment. So I does the experiment, I performed the experiment and I got similar result, right? I got 25% for 0 outcome, 50% for 1 outcome, and another 25% for 2 outcome. So that is, I mean, you can test the same rule for even 3 coin tossing or 4 coin tossing. Just work out that 4 coin tossing, what are the possible micro states and what are the possible macro states. Write down and write the program, compare the results. For 4 coin tossing, what are the possible macro states? Macro states are 0 head, 1 head, 2 head, 3 head, and 4 heads. 0, 1, 2, 3, 4 are the possible macro outcomes. What are the micro outcomes for that? Just write that, get the probabilities, then we'll verify it. Otherwise, yeah, go for 3 coin tossing, simple. That is more easier. Go for 3 coin tossing, possible micro states and macro states. So micro states will be studied later. First of all, I'll go for macro states. So macro states are what? 0, 1, 2, and 3. These are the macro states. And what are the micro states? For 0, heads, all the 3 tails. And for 1 tail, what are the possible micro states? THH, HTH, HHT. That's all right. Is there any other possibility? So for 2 heads up, what are the microstates? HST, HTH, THH. 2 heads up. Sorry, what am I talking about? One head only, right? These I need to edit. 1 head up means TTH, THT, TT, oh, sorry, HTT. That is for outcome of 1 head up, possible microstates. And for 3, it is HHH. So how many microstates are there? 8 microstates. There are 8 microstates and 4 macrostates. So this gets 1/8 probability. This gets 3/8 probability. This gets 3/8 probability. This 1/8. Right? So in terms of percentages, 1/4 is 25, 1/8 is 12.5. 12.5% and 3 12.5. 25 plus 12.5. 37.5%. Another 37.5%. Another 12.5%. So the outcomes are 4. They are not equally distributed. Microscopic outcomes are equally distributed. So let us check. What do we get? So extend the program to tossing 3. Write that tossing 3. You can just copy paste and add 2 more lines. Tossing 3 dot yeah. So I'm adding 2 more lines for coin 3. A3 is equal to rand 1 comma 100. B3 is equal to A3 less than 0.5. B is equal to B1 plus B2 plus B3. End of the story. What is the outcome? A3 చేయాలి. Okay. Right. So did I get the expected outcome? 12, 37, 37, 12. What did I get? 12, 40, 32, 16. So if I run the experiment again, this is more reliable. 14, 38, 34, 14. So like that, we are nearer to expected outcome. This is the expected outcome. 12.5, 37.5, 37.5, and 12.5. And we are getting result nearby that. So to get a better result, raise everything to 1000 tossings. Raise every count to 1000. Then these fluctuations will be minimized. So now 125. Out of 125, how many you have got? Yes, you got 126 for case 1 and 385 for case 2, 377 for case 3, 120 for case 4. So if you raise all the counters to 1000 coin tossing, the decimal error will be avoided. So with this, I'm closing the session. Now the floor is open for discussion and feedback. Of that, we'll have valedictory. So whatever programs were written here will be distributed in WhatsApp, or yeah, will be distributed in WhatsApp. So I again got experimental outcome is matching with probabilistic predictions, statistical predictions. Close to message and check. Right. So with that, the technical session is over. Day 2, session 2 of this 2-day national workshop on MATLAB or Octave for Physicists is over. So now, any feedback or any suggestions, whatever, final words about these 2 days, 4 sessions? So of this, in another 5-10 minutes, the validatory session will start. Meanwhile, and we need to collect the feedback. So it is a part of documentation. So please feel free to give your feedback genuinely. Padmavati madam, Devan sir. Sir.
Good afternoon, sir.
Sir, really, simply I can say excellent, sir. Excellent. Am I audible, sir? Hello? I think we are not able to hear you. Hello?
1 second, madam.
1 minute.
Let me. Okay.
Sir, simply I can say excellent session. Within these 2 days, I have learned really means basics about MATLAB, and I'm able to do on my own. And thank you so much, really, for giving this knowledge to me. Thank you so much, sir. And your way of explanation is very nice. Even who don't know anything about MATLAB, they can follow and they can learn. That is really great thing. And you have taught us, really, I don't know anything about MATLAB. From ABC, I have started. Now I am able to do. Thank you so much. And I hope definitely I will continue this. In case if I get any doubts, I will contact you definitely. Thank you so much, sir, for giving this opportunity. Sir, your voice is not audible.
Yeah. These can be incorporated into our UG curriculum. That is what we are planning.
Yes.
I mean, our next workshop may be for all faculty, and title would be
whatever we are
MATLAB
learning,
for
that
UG physics.
Yes, sir. Definitely, whatever we are learning, that is for the sake of our students only. If we know, then we can incorporate to our students. That's why. Thank you very much.
Yes.
Sir.
Thank you. Srinivas, sir.
Sir, very good afternoon. I think I am audible.
Yes, sir, audible.
Sir, the workshop really went very good and handy for me, sir. I really thank the organizers. Hello?
Mere college అంటున్నది కూడా ఒకసారి చెప్పి.
Sir, I am assistant professor from Dr. SRK Government Arts College, Yanam.
Sure, sir. Thank you. Okay, sir.
I got this information through your principal, sir, from his WhatsApp status, and I could able to register from there. And I really look forward for this kind of sessions actually. So I will encourage these workshops to be for undergraduate students because it will enhance their learning and it will lead forward for their career also. This kind of workshops are really needed in the hour. And I thank you very much for handling this workshop very nicely. And the problems that you have chosen in this workshop is very, very nice, sir, and very informative and easy to understand also. I thank you very much for taking this workshop. And if at all if this kind of workshop is there, please inform us, sir, so that our students are also can able to attend this program. I thank you very much, sir, once again. And I congratulate Government College Rajahmundry to take this kind of programs forward. Thank you very much.
Thank you, sir. Thank you. Anybody else? Devendra sir, Venkana sir, Venkatama garu, Chinna Venkatama garu. Okay, Madam garu. And any offline participants?
Hello, Sanjeev Garu. Am
Madam
I
garu.
audible? Am I audible?
Yes, ma'am. Yes, ma'am. Audible.
Yeah. So this is a good workshop for all the mathematicians, those who are studying mathematics. Very powerful mathematical oriented syntaxes you have explained. And this Octave and MATLAB both are useful software techniques. So you have taken a good examples and explained to the students. So this type of workshops really it's very wonderful and very useful for all the mathematics students, especially in our combinations, all the combinations, not only physics.
Yes, ma'am.
Isn't? Yes.
So soon there is one more proposal is also there, like multidisciplinary workshop on MATLAB for physics, chemist, botany,
For all
zoology.
the, yes.
Yes,
For
for
all
all
the
sciences.
disciplines. Yeah, it's good.
Yes, ma'am. That is also under process.
Okay.
Thank you, ma'am. Thank you.
Okay,
very much.
thank you.
And any offline participants? Take your turn. Name and your affiliation and then your feedback.
My name is Abdul. I'm studying for first BSc Statistics.
This.
సార్ చాలా క్లియర్ గా చెప్పారు. నాకు ఫస్ట్ టైం విన్నాం ఈ మ్యాట్లాబ్ గురించి. సో ఈ ఎక్స్పీరియన్స్ చాలా బాగా అనిపించింది. థ్యాంక్ యూ సార్. ప్రతి పాయింట్ ని క్లియర్ గా చెప్పారు. థ్యాంక్స్ ఫర్ దిస్ ఆపర్చునిటీ సార్. థ్యాంక్ యూ సార్. వద్దు సార్. వద్దు సార్.
Whatever it is.
తెలియదు. సార్ ఈ లోపు అక్క మంది చెప్పమనండి, నేను చెప్తాను. అనిత కుస్మక్క సరే నేనే చూపిస్తాను. కనిపిస్తాను. My name is Rama Banasri and I'm studying MSc in Government College Autonomous. I have physics and I have a wide clarity about MATLAB and I know about the basics of MATLAB. Thank you for giving me this opportunity to the Department of Physics, especially Sanjeev sir. Thank you, sir, for your clear explanation.
Anybody else?
I'm Sheikh Shahida from 2nd MSc, studying in Government Autonomous College, Physics. And ఈ MATLAB అనేది చాలా బేసిక్స్ నేర్పించారు MATLAB లో సార్. అండ్ ఇది మా పీజీ
ప్రాక్టికల్స్ లో కూడా చాలా యూజ్ అయ్యేవి చాలా చెప్పారు సార్ బేసిక్స్. సో థ్యాంక్ యూ సార్, చాలా క్లియర్ గా చెప్పినందుకు. అండ్ ఈచ్ ఆపరేషన్ ఎలా వర్క్ అవుతుంది అనేది కూడా ప్రోగ్రామింగ్ అనేది చాలా క్లియర్ గా చెప్పారు సార్. వి ఆల్ అండర్స్టాండ్ సార్, అండ్ థ్యాంక్ యూ సార్.
Thank you. So, I mean, that is actually the basic advantage with MATLAB. Every code is human readable and simple. Whatever we did today is at most minimum 1-2 lines to 10 lines maximum code we have written today. So that is the actual advantage with MATLAB, and I'll just pass the information on to you. That's all. So being a regular user, I mean, I have organized the content into a more sophisticated way. That's all I did. The actual freedom is gained through the software itself. So with that feedback and all, I'm closing this online session of day 2, session 2 of 2-day national workshop on MATLAB and Octave for Physicists. So now we proceed to valedictory section. Valedictory session, it will be in the seminar room. We'll continue this online session in a few minutes. I mean, the valedictory session continues. Ma'am.
In differentiation and integration programs, you have written double equal. Why, sir?
So there we are defining it as a new variable. The entire equation is being defined as a new variable. The two possibilities are acceptable. Both possibilities are acceptable. Let's say I'll show that. And we tried both possibilities and both are acceptable.
Double time equal to symbol.
That's what we are defining entire equation as a variable. There we require that. So integration.
Here, equation 1 equal to y double equal. Yes.
That is what this entire equation is being stored as a variable eq1.
Okay.
That is why to distinguish that we are using double equal to. Otherwise we can use another syntax. This one. I mean, there you have to use you have to mention y is a function of x. Then you can directly assign it to. So you can use the variable y itself as a variable. The function y itself as a variable. That is direct way. This is indirect way. We are defining entire equation as a variable, and we are trying to solve the equation. Here we are trying to solve the function. Here the input for integration is y, the function.
Yes, sir.
Whereas here the input for the function is this equation, this variable. eq1 is a variable.
Yes, yes. Nice.
Both are
Thank
acceptable.
you very much, sir. Yeah.
Okay,
Super.
thank you. See. So this session continues for valedictory.